it turns out the areas of these two shapes are the same, or they can at least be worked out in the same way. And the reason why is because you build them the same way, right? Rhombuses are a special kind of kite, if you want to think about it like that. So what we've got here, what we'll need is, rather than like length and breadth and all that kind of thing, is what you need to draw is the diagonals of your kite, okay? So connect up the opposite points, and let's get our diagonals in the picture.
Can it be normal? Like facing normal?
Yeah. Facing whichever way you like. Now, if you have drawn your kite accurately, and you've got two pairs of sides that are actually equal to each other, then when you draw the diagonals, you ought to notice something a bit unusual, right? That the diagonals, they meet in a particular way. And if you can look over at your neighbors, whose kite hopefully looks a bit different, your diagonals, their diagonals, should do the same thing, even though your kites are different. You can even see it on mine, roughly. What is it about these diagonals? How do they meet? How do they intersect? Okay, so you got diagonals here of a kite, and thank you very much, Andrew and Peter. They are at right angles. They're perpendicular. Okay. And here's the thing, though. You can't just kind of say, "Oh, they look kind of perpendicular," right? Things often look like something, but it's not enough to just say, "Well, that's close enough," right? We're mathematicians. We can prove that it's perpendicular. No matter what kite you draw, we can do it. And in fact, the whole point is that all different kites, it'll work. Okay. So here's now my question. Right? I have a question mark here. I'm trying to work out what is that angle. Can I prove that it's equal to what we think it is equal to? Okay. How are you going to go about doing it? All right. So you got your diagram there. We're going to put some labels on this. Okay. So firstly, have a look at this with me. See how these two sides are equal to each other. Yes? Okay. So I'm going to label them as such. So that equal to this. Can you see it? Is that reasonably clear? Yep. Yeah? Okay. And then you've got these two equal, right? So I'll mark them as such as well. Okay. So what kinds of things do you notice? Well, have a look at this top triangle, right? And the one that is opposite underneath, okay? Can you see that those triangles, the top one and the bottom one, they have so many things in common, right? How many things can you see? Jake?
They have the two sides that are the same, and they share both of them. Sorry.
Yeah, good.
And then they share the same base.
Right, very good. Okay, I'm going to stop. I'm just going to draw it. Okay. Very good. That's exactly right. So you've got two pairs of equal sides, 1, 2, 1, 2. And then you've got this one in the middle. It's the same side, so we call it a common side, right? So therefore, these two triangles, the top triangle and the bottom triangle, likely to have this on the side of your diagram there. Now, we have a special word for when shapes are not just a little bit alike, but exactly alike. It starts with a C. Does anyone know? Congruent, very good. So we've got two congruent triangles. It means in every single way, all the angles, all the sides, everything, the triangles are the same. Okay? They match up. If I were to flip them around, they'd sit exactly on top of each other. I know we're upside down, but they're still the same dimensions, same size, all that kind of thing. So if they're congruent, we can say some things about the angles. For instance, I'm going to take this one off now. So see how you got this angle and this angle, right? See how they match. They're the same angle, just upside down from each other, right? So I can say they're equal to each other. Is that all right? So for example, I can put alpha and alpha there. I can say they're equal. Is that all right? Are you content with that? They're both the same. All right, the next thing I want you to notice is, hold on a second. Look at this left-hand triangle, right? We talked about top-bottom before, but now have a look at this left-hand triangle. I'll outline it for you. This one here. What kind of triangle is this red triangle? It's isosceles, right? Good. So it's got these two equal angles. When you've got an isosceles triangle, what can you say about it?
They have two angles.
I've got two equal sides. That's what I knew already. Which means I've also got two equal angles. Which ones?
The opposite ones.
These top and bottom ones, right? So I can say they're equal as well, right? So let's give another name to these ones. Let's call this one beta. And this one's beta. Is that okay? Yeah, so far so good. Alright, now have a look at this red triangle now. I now know what the angles all in this triangle are all equal to, right? This red triangle, if I draw it like this, off on the side, okay? You've got beta here, beta here. What's this angle equal to?
2 theta.
I've got 2 of these, right? Except for the fact that it's alpha. But yes, that's exactly right. It's, you were so close. Okay, there you go. 2 alpha. Okay, yeah, you can draw this on the side. So now we can work out what this thing is equal to, right? All of the angles in a triangle, 2 alpha plus beta, right? What do all the angles in a triangle add up to? 180 degrees, very good, right? That's the angle sum of the triangle. So now help me out here. We can make this a little bit simpler, a little bit, right? I've got 2 alpha and I've got 2 beta. And then I've got 180 degrees over here. Yep. So I can divide everything through in this line by what's the common factor? What do all of these numbers have in common? I can take out a factor of 2, can't I? All those numbers are even, right? So I'm going to divide this by 2, this by 2, and this by 2. See that? Do the same thing to everything, okay? See what's going on? Okay, so you can see it. These 2's are going to cancel, you just get alpha. These 2's are going to cancel, you'll just get beta. And then you do 180 degrees divided by 2, which is 90 degrees. All right, now why is this significant? And why does this get us to what we were after, right? Come back to your original kite, right? And I hope you've got your kite there, it might look a little bit different, right? See how alpha and beta are here in this triangle? Right? Well, I'm going to do that whole angle sum thing all over again, right? Alpha plus beta, they're 90, right? So I've got one last angle. And it has to be 90 degrees in order to get the 180 that a total triangle has to be. Okay? So now I'm not just guessing, and I'm not just saying, oh, it kind of looks like it. I've proven it. The logic holds. No matter what kite you present to me, all 30 kites that are in the room, they're all going to have the same properties, even if they all look different. Does that make sense? Okay, so what was the whole point of that? The whole point of that is now we can get an area out of this, right? I need one more color. Right? We put diagonals on here, okay? So let's call this up and down one. We'll call it X. So all the way up and down is X, okay? And all the way across, we'll call that Y. So what's the area of this thing now? Remember, you've got a right angle in here, don't you? Okay, you've got a right angle in there. So how can we take advantage of that? Oh no, I'll leave that. I'll rub this on.
Supplement, no, what's it called? What angle on a straight line equal to 180?
Yes, good. So you got 90 here, which means you have 90 there as well. So in fact, all of those, they'll all be 90. Okay. Here's the way I'll help you out, right? Let's come back to this top triangle, right? Because once you say something about the top triangle, you can say it about the bottom one. Okay? What's the area of that top triangle? We already know how to do triangle areas, right? It's half base height, right? Half times, what's the base of that top triangle? It's y. Half base. What's the height? Hold on. Be careful here.
Half x.
Yeah, all the way from here to here is x, right? But we just went to the point of saying the top and the bottom triangle are the same. So this should be the same as this. So that should just be half, right? Half x. Okay, right. So let's put this all together. Yeah, I'll say it again. So I'm doing half base height, yeah? Half, the base is y. There it is. And the height is this bit here. Look at the top triangle, okay? If this all the way is x, then this is halfway. Therefore, half x. Is that okay? All right. I'm so close. We're so close. Half times a half. Half of a half is a quarter. Right? And then, rather than just writing all these multiplication signs, I'll just say x, y. Okay. So that's the area of the top triangle. if the top triangle is congruent to the bottom triangle, what's the area of the bottom triangle? They're exactly the same in every way, right? It should be the same, right? So this should be the area of the bottom triangle as well. Yes? So therefore, the area of the kite, the total area, it's this, and then this again, because I got two of them. Two of those triangles, right? We halved half there, and we got a quarter. Well, now we want to put one back, right? So two of those will just be half. There's your area formula, right there. Okay. Now the cool thing about this, and the reason why I had all my extra sides before, right, is that a kite and a rhombus are really the same kind of shape. It's just that the rhombus has more equal sides, right? So you got this guy over here, and then you got this guy over here. So therefore, not only is the area of a kite half xy, half times the diagonals, right? But the area of a rhombus is also the same. So long as you have its diagonals, you have its area. Similar kinds of shapes, same formula for working out how much space it takes up. Yep.
How did you get, are they both just equal?
These two angles, why are they equal? Because you've got the top triangle and the bottom triangle, everything about them is equal. That's what we mean by congruent. So if everything about them is equal, then the angles are equal. Okay. All right. You did a really good job to follow along with that. Here it is, I promise. This is the last sheet on any of these.